Hey everyone, today we are going to start section 7.3, which is equations of lines. The part that we're going to focus on right now is this, the equation of the tangent line, and then we'll do this part about the normal line tomorrow. So today we're going to focus on the tangent line and its different applications. All right, so the first thing that you need is this formula. The equation of the tangent line at a particular point is given by this formula. This formula is not in your formula book, so you need to be familiar with it. So we would have seen this in Algebra 2, like y minus y sub 1 equals m times x minus x sub 1. This is the same formula. So your point up here is really the point x sub 1 comma y sub 1, and your gradient right here we would have used the letter M. So this is a formula we have already seen in class, although not very often. We did a little bit of this in topic 6, but mostly you would have seen that in Algebra 2 if you can think back to where you were there. Now, if I want to, I can rearrange this into gradient intercept form, which you remember looks like that. And then if the question asks you for standard form, what it's asking for is that. So whatever format it wants the final answer in, this one, or this one, you can rearrange from what's in the pink box to get that particular format. Okay, so let's do a practice question. Find the equation of the tangent to f of x equals x squared plus 1 at the point where x equals 1. Well, I see the word tangent. When I see the word tangent, that's going to make my mind think derivative. So I'm going to take the derivative f prime of x equals, I'm going to take that 2 and bring it down in front of the x, 2x, 2 minus 2 is 1, my new exponent is 1, and then the derivative of 1 is 0. The derivative of a constant is always 0. All right, so my derivative of that particular equation is 2x. Now remember, the derivative finds for us the equation that is the gradient for the tangent line anywhere on the curve. And I want that specifically where x equals 1. Okay, so let's do that. Let me change pen colors here. All right, so I'm going to do f prime of 1, 2 times 1 equals 2. Okay, so what we have found here is the gradient of the tangent line to this particular curve at this particular point. Well, if you look back at our line equation, let me flip back there. You see in our line equation, we have this part now. We have f prime of x. We have this part. The x value, original x value was given to us. What we need to find is this part. We need to find the y value. Okay, so let's go back over here. All right, so if I know an x value and I know an original equation, I can just substitute in to find the y value that goes with it. So I'm going to do f of 1. Notice there's no prime on this one. This is just the original equation. So I'll substitute in 1 for all the x's. 1 plus 1, which is 2. Okay, so now I have y sub 1, which is here. I have m, which is here. And I have x sub 1, which is here. So I have now everything I need to substitute into that equation. All right, so let's do that. Y minus y sub 1, which we found in the purple, equals m, which we found in that maroonish color, times x minus x sub 1, which is given to us. All right, now regardless of which format that we want, we can go from here to get it. So if I wanted gradient intercept form, I'll distribute the 2, add 2 to both sides. All right, if I want standard form, I'm going to start the same way. I'm still going to distribute the 2 like I did right here, but now I want to move the y and the negative 2 from the left-hand side over onto the right-hand side, so I'll end up with 0 equals 2x minus y, and negative 2 plus 2 would cancel out. So whichever format they ask you for, you can adjust to that format from the original substituted equation. Okay, so let's look at this one. We have this curve, x to the third minus 4x squared minus 6x plus 8. And I want to find the equation of the tangent line to this curve at the point where x equals 0. Okay, so let's do that first. So pause the video. I want you guys to all find the gradient on your own. Find the gradient at the point where x equals 0. So pause the video, and then we'll come back together and do that together. Watch your notation. Okay, so let's see. You should turn the video back on, and let's see what you got there. So y prime equals 3x squared, moving that 3 into the front, and then 3 minus 1 is 2 on the exponent, minus, okay, now on this one, I'm going to move that 2 into the front. 2 minus 4 is 8, x, and then the 6x, remember that has that understood 1 exponent right there, so 1 times negative 6, negative 6, 1 minus 1 is 0, so the x becomes 1 and just multiplies away, and then the derivative of any constant is 0. So there's my derivative. And hopefully you remembered that you should substitute 0 in for all your x's because that's what you were given. And you end up with negative 6. Okay, so now analyze what you have found here. You have substituted a value into the derivative. So what does that find for you? It finds for you the gradient of the tangent line. So now I know m. I've got m equals to negative 6. I've got x sub 1 up here. So what am I missing to substitute into my equation? Okay, what I'm missing is y sub 1. Okay, so let's find that. Let's take our x value of 0 and substitute into the original equation. And I end up with 8. And that is my y sub 1 value because I used the original equation. Okay, so now I'm going to use that equation from a couple slides ago, and I'm going to substitute in y minus y sub 1, which I just found to be 8, equals m, which I found to be negative 6, times x minus x sub 1, which I found to be 0. All right, because I know what I'm wanting to do ahead of time in question B, I'm going to work on this one to get it into gradient intercept form. I'm going to get y by itself, so I'm going to distribute the 6 over here, negative 6 times x, negative 6x, and negative 6 times 0 is 0. All right, and now I'm going to move that 8 over to the other side, negative 6x plus 8. Okay, so now I'm going to go put that, let me get rid of that x. Oh, I need to. All right, and I'm going to go write that up here. Negative 6x plus 8. Okay, because I need to erase the rest of this screen so that I'll have space to do the rest of the question. And so I need a place where I can just remember that particular thing. So let me erase all the work we did here. Okay, now part B says, at what point, okay, so I know automatically my answer is going to be a point, does this tangent meet the curve again? All right, notice the vocabulary here. It has the word meet. It doesn't say it's going to be tangent again. It just says it's going to meet again. So if you look at what we have here, I have two different equations, and I want to know their point of intersection. Okay, so I'm going to pick up my calculator. Hopefully you guys all got those out already. If you did not, pause the video, open up your calculator. All right, the calculator is not, you have to push all the buttons. There you go. Sometimes I try to do it without that, like pushing them on the screen. It doesn't work. All right, so I'm going to go to the y equals screen, and you can see I already have that first one and that second one put in there. Okay, so pause the video for a second, type them into yours. And then I'm going to graph. So I'll put it in the standard window like you guys have. Okay, so I can see right here where it's tangent. What I'm looking for is this other point down here. All right, so I can see that I'm far enough on the x-axis, but I definitely need to go down farther on the y-axis. So I'm going to go to Window and go down, change my y-min. I'm just going to change it to 30, which is just a guess. If 30 doesn't work, I can always go back and change it. All right, so there's my x to the third curve. There goes my line, and the point I want is this one right here. Okay, so if you guys remember, you hit second trace to get to the calculate screen. Go down to number 5, and then hit enter. Okay, so I'm going to go ahead and move my cursor over here. Remember, you can only use the right and left buttons to move your cursor, so I'll move it over there. This one doesn't have the nice colors like our yellow ones do at school. So Y1, is that my first curve? Why, yes it is. So I'll hit enter. Y2, is that my second curve? Why, yes it is. So I'll hit enter. Now, is where I have my cursor blinking a good guess? Yep, that's a pretty good guess. So I'll hit enter. And there we go. The answer to this question is the point for -16. Sorry, I can't have the calculator on the screen and write on the screen at the same time. But there is where the answer is going to come from. So that's the point where that particular tangent line happens to meet the curve again. And notice it is not tangent at that point. It's cutting through, not touching. So I went to Desmos so you guys could see. All right, and do you see how it's tangent right here at the point 0.08? You can see the red one is going right across the blue one, but not going through it. So that's what a tangent line looks like. And then you can see down here that it's just crossing through it. It is not meeting it at that point. So it's not tangent at this particular point, even though it is tangent up above there. Okay, let's keep going. All right, so what we're going to do is we're going to learn also how to do this on your graphing calculator. So these directions that are on this screen, these will work with the yellow calculators we have at school. So if the calculator you happen to have at home is a TI 84 plus CE, just like we have at school, then you want to pause the video here and write these instructions down somewhere because these are the instructions that you're going to use. If you're using the calculator on the screen, you're going to use these. Okay, so that's what I have is the calculator on the screen. That's probably what most of you have. So I want to show you how to do it with this one. So I'm going to go to my y equals and I'm going to clear out what's in there. Okay, so in y1, if you look back, my directions were to find the gradient of the tangent to this curve at this point. Okay, so I just copied the curve over here. So I'm going to put that into y1, x to the third plus 3. Okay, now it says to go to the home screen. So I'll go to quit. You guys see the little yellow quit right there, second quit. And then I'm going to hit the math key. And I'm going to go down to number 8, n derive, which means a numerical derivative. So instead of finding the equation for the tangent line, it's going to find a number. It's going to find the equation at a specific point. And then I'll hit enter there. Okay, so what it says is the parameters, the things I'm supposed to type in, starting with the expression. Well, I saved the expression in y1. All right, so to get to y1, I don't know if you guys remember this. We did this several topics ago. I'm going to hit vars, go over to y vars, and this is a function, and the function is y1. So I'm going to hit enter. Okay, and then you can see right here I have to hit a comma. That's not attached to the one. That's separate from the one. And then the variable that I need, well, my variable that I'm working with here is x. Now, comma again, so I'll hit my comma. And then the point where I want to find the derivative, which on that last screen, it told me that point was going to be -2, close your parentheses, and hit enter. Okay, now you have to be smarter than your calculator. The answer is this part right here. The calculator goes through a process to find this for you, which creates all these extra decimals. But you can see from this right here that if you were to take the derivative of that, 3x squared, and then substitute in -2, you are not going to get a decimal answer. That's going to give you an integer answer. So just pull off the integer part there, which is 12. Okay, so now we have found basically that f prime of -2 equals 12. Okay, so what if the directions, instead of saying write the gradient, they said write the equation of the gradient line, or I'm sorry, the equation of the tangent line. So then what we have found right there again, that's m. What you have this x value right here, that's x sub 1. And if I need y sub 1, okay,